Question 4 is a centres of mass question, probably one of the more ugly centres of mass questions I've ever worked with. We've got a uniform laminar, so a two-dimensional object, where we've got a quarter of a circular disc of radius 4, and we've got these things about where the points are, and then we've got this uniform laminar ABCD as shown in figure 1. We're told something about where the centre of mass of the disc is, and we have to work out the centre of mass from the line AD. So we want to work out where it is from that sort of horizontal line that moves across. The first thing I'm going to start by doing is just to add on some further information that is going to help us answer this question. So the first thing is if I just drop a little perpendicular down at this point, we know that because of the way this is set out, in the fact that these two sides are the same length, that we would have both of these angles in here as being 45 degrees. So if I drop a perpendicular at this point, then both of the angles at the top are going to be 45 degrees, and what I've then created is two smaller isosceles triangles. Now that's useful because I can then work out the side lengths for these isosceles triangles. The longest side squared would be the 3 squared, which is going to be equal to both of the shorter sides squared, and because they're both the same, that's going to be x squared plus x squared, so that's 9 is equal to 2x squared, so 9 over 2 is equal to x squared, so we've got there 3 over root 2 is equal to x. So these sides here, which I should probably put in a different colour, these sides in here are going to be 3 divided by root 2. Now this helps me because I'm going to set up a coordinate system, assuming that my centre here is going to be my point 0, 0, and then I'm going to work below that and to the left, so the point here, D, is going to be the coordinate minus 3 over root 2 minus 3 over root 2, and on the other side my point A is going to be 3 over root 2 and minus 3 over root 2. Now why am I doing this? Well, I need to find the centre of mass for the triangle. What I'm going to do, let's think about how we're going to show this. So I am going to have this sort of sector laminar. I'm then going to remove the triangle, and what I'll be left with is this sort of little piece that I want, which is the bit that sort of looks something like that. For each piece we're going to need to know the mass and the centre of mass, so let's put down mass and centre of mass. The masses are easy to fill in, so we've got here a quarter of a circle, so the full circle would be 4 squared pi, so we've got a quarter of 4 squared pi, which is a quarter of 16, which is 4 pi. For my triangle, now if I go back to the top here and I see that this is drawn in as a right angle, so I've got a base length of 3 and a height of 3 effectively, so I'm going to do 3 times 3 divided by 2, so that's 9 over 2 for the mass of the triangle, and then for the piece that I actually want, that's going to be the 4 pi minus 9 over 2. Now for the centres of mass, so back to my sector, I was given a formula down here for the centre of mass, so that's going to be at a position below the point 0, 0, so the centre of mass is going to be 0 in the x direction and minus 4 root 2 times 4, so that's 16 root 2 over 3 pi. Now comes the point where I need these coordinates that I set up, because I know that to find the centre of mass for a triangle I just want to do a third of the sum of its vertices, so that's going to be a third of 0, 0 plus minus 3 on root 2 minus 3 on root 2 plus 3 on root 2 minus 3 on root 2. Now you might be asking yourself at this point, why am I bothering to calculate the x coordinate, because we know that's obviously going to be 0. I'm afraid it's just force of habit. So that comes out to be 0 minus 6 on root 2, which is the same as 0, and 6 divided by 3 is 2, so that's minus 2 over root 2, and obviously if we do 2 divided by root 2 we just get root 2, so the centre of mass here is going to be 0 and minus root 2, and the centre of mass for my last system is going to be x bar y bar. Now it's time to do a little bit of calculation. Sort of run out of space there, so just scrolling down, need to use all of that information. So I've got mass times centre of mass to do now. So I've got 4 pi times by 0 minus 16 root 2 over 3 pi. And then mass times centre of mass for the second one, so I want to take away 9 over 2 lots of 0 and minus root 2. And then that's going to be equal to the mass for the total system, which is 4 pi minus 9 over 2, lots of x bar, y bar. Give myself some more room. Multiplying this through, we've got 0, and that's going to give me minus 64 root 2 over 3. Next one is going to be minus 0, and then that gives me minus 9 root 2 over 2 is 4 pi minus 9 over 2, lots of x bar, y bar. Now I can mess around with fractions a little bit and think of this as being 0 and minus 128 root 2 over 6, and minus 0, and this being minus 27 root 2 over 6. Minus minus is going to give me plus, filling in the rest of this. So collecting on the left hand side, we're going to have 0 and minus 101 root 2 over 6 is equal to 4 pi minus 9 over 2 x bar y bar. And then throwing that onto my calculator and working to 3 significant figures, I've got the centre of mass being 0 and minus 2.95 for x bar y bar. Now, just reading back, I want to find the distance of the centre of mass from the line AD, and what I've done at the moment is to find the distance of the centre of mass from the origin. So I know that it's some sort of position down here, and that total distance from top to bottom is minus 2.95. What we're actually interested in is just this bit that I'll colour in blue, shall we say, is just this little bit in here. Don't know what's happened to my cursor at this point. So I need to get rid of this red section up above, which we had established earlier was 3 over root 2. So the final calculation that I'm going to do is just to say, where am I at? That I want to do 2.95, and I want to get rid of 3 over root 2. I want to get rid of the top section from that, which is going to leave me at 0.83. So my answer for part A is 0.83 below AD. Right, that's for part A. Part B. The laminar is freely suspended from D and hangs in equilibrium. Find to the nearest degree the angle between DC and the downward vertical. Now, you can never be 100% sure of these things, but I am fairly confident that the exam board have made a mistake in what they've asked for here. Only because this is far more complicated than is usually asked for. So we draw on the downward vertical between D and the centre of mass, and the angle that we've been asked for is the angle between this downward vertical that we've just drawn on and DC, which is this side. I'm fairly confident that they made a mistake here and wanted to get you to find DA, but there we have it. The question has been asked, so we're going to go about solving it for what they have actually asked for. What I'm going to do is think about the larger triangle to start with, involving the 45 degrees at the top. I'm going to use the fact that I know the length here in red to be 3 over root 2, and the fact that I've just worked out that this side in blue here is 0.83, to be able to calculate this angle here first of all. So that would be, again thinking about where we're going to put the working for this, so let's write that down over here to say that tan of this angle theta is going to be the opposite, which is 3 over root 2 divided by the adjacent, which was 0.83, which then gives me an answer here for theta of 68.6 degrees. So thinking angles in a triangle, so you can do this one of two ways. So you can either add together the 68.6 to 45 and subtract from 180 to find out your missing angle on this side, and then subtract that from 180 to find your missing angle. Or you can use the, I think it's called the exterior angles theorem for triangles, where the exterior angle on this side will just be equal to the sum of the two angles on the other. So to find my final answer for, let's call it alpha, alpha will be equal to 68.6 plus 45, and we were told that we wanted to the nearest degree, so my final answer for alpha is going to be 114 degrees. Now, as I say, I'm fairly confident that they were meaning only to ask for dA in that question, because if not, there's a substantial amount of work that's had to go into to get that for the 4 marks. But hey, maybe it makes up for the previous question where we didn't have to do that much to gain 6.